Welcome to the Maintainable Software Podcast, where we explore the art of improving existing software with seasoned practitioners who have helped organizations overcome the problems often associated with technical debt and legacy code. I'm your host, Robby Russell. On this episode, Chad Fowler. Yes, Chad Fowler. Chad is an experienced technologist, software developer, public speaker, saxophonist, and was co-author of one of my favorite books, The Passionate Programmer. Chad is currently a General Partner and CTO at BlueYard Capital. Chad joins us today from Arkansas. Chad Fowler, we're so glad to have you join us on Maintainable. Welcome.
Thank you. I am glad to be on Maintainable.
So as you reflect, Chad, on your experience in the industry, what do you believe are a few common characteristics of, dare I say, well-maintained software?
I guess the first one I could think of is that it changes somewhat frequently at the behest of users who are actually using it. Is that one or is that two? Users use it and it changes frequently. Although I guess that's also a slippery slope because maybe some software doesn't need to be changed. No, that's not true. All software needs to be changed.
You know, it's interesting thinking a little bit about a lot of people will, I've talked to people on the podcast or how I see people kind of evaluate things like third-party libraries they might use in your application. And they'll look at like how often the code base is updated. And if there's not been any commits in, say, a GitHub repository or something in a while, they see that as not being actively, air quoting, maintained anymore. But do you think that's an accurate way to kind of portray software?
I think it is, although that sounds like it would be wrong if you just like lay out the facts sort of from a third party perspective. It sounds like it would be wrong because if the software does what it's supposed to do and users are still using it, then why should you change it? But I think the reality is that software systems that exist in the wild and are being used and are alive can't continue to be healthy and well maintained unless they are frequently touched. And there are probably a couple of different ways that this specifically manifests. One is just the fear of coming back to it and the decaying knowledge. Like I think there's a thing about maintenance that is how capable are the maintainers, whoever those are, in terms of being able to change it if they need to. And if you don't do something regularly, you're probably not going to be good at it. So if you don't change a piece of software regularly, especially if it has any level of complexity beyond triviality, then you probably won't remember how you were doing things back then or how the code was organized. And you might not be able to get it to work. The other angle is dependencies, like you said, may actually break things. So like a specific example I have that kind of led me to this is when I was working on Wunderlist, we had one service out of tens of services because we had this like radical polyglot microservice architecture we had built. One service, it was called root, and it was part of our sync protocol. And it was the top level of our sync protocol, sort of the most important service. We wrote that one service in Haskell. And what I learned in building code in Haskell over the years, and this service was no exception, is if the Haskell compiles, then it probably also works. It's probably correct because it's hard to write things that aren't right. It's hard to create bugs in Haskell. I know that sounds like a crazy claim, but it really is true anecdotally for me. We had this one service, no one ever had to change it. And also there were only two of us who were willing to learn Haskell and, so me and the other nerd. And it was the fastest service we had, never had a problem, never had an outage. It used a tiny percentage of the server resources as all the other services we had, even though it was doing as much work or more. And therefore we didn't touch it. When we were acquired by Microsoft, one of the things that we had to do was allow a third-party auditor to build all of our software again and deploy it so they could prove that it was possible. And I guess this auditor, I should try to remember who it was because they'd be a great guest, I'm sure. I guess what they were doing was trying to figure out just how well maintained and maintainable this software would be. So they would go try and set everything up themselves. That's a really interesting thing as an aside. Imagine as a software developer on a long-term project that suddenly next week, some people you've never even heard of have to deploy this code from scratch in a new service. That would change how you think about how you're doing things. You probably shouldn't necessarily build toward that. Anyway, they had problems with this service, and it was really disturbing because what had happened is the package manager for Haskell had changed. This thing called Cabal had changed in a way that it wasn't compatible with how we had set things up. And there was actually a broken piece of the dependency chain. It was literally impossible to get this service to build. So if we ever had to change it again, we would not be able to. Terrifying. And it was because we hadn't changed it frequently. So we were just so out of like the loop of what needed to happen to keep the software going that we were no longer capable of doing it. It was on our quote unquote best code.
That's a great story. And thinking about when there's projects that seemingly do what they're supposed to do, you feel like it's a stable platform, it's hosted. It ends up being when you need to like set it up again somewhere else or bringing on new people into a team. There's these kind of inflection point or these points where it kind of highlights that this may not be so simple to replicate. And that idea of bringing in potentially another company to come in and have to like so it wasn't that they rebuilt it, they were just rebuilding the platform that it hosted, or they weren't necessarily rewriting all the code itself.
Right. They were just trying to get everything to compile and run. So sort of like they could go tell Microsoft, okay, this isn't a big pile of junk that you're buying.
Right.
You know, that it works.
I've been on the auditing side for some of those, like some acquisition type projects. And so that would be something that we would talk about. Like these seem to be really difficult things for us to spin up, or we hit some weird issues and this is not documented. You know, we would need to talk to the original people probably to make sense of this, or a lot of time to figure it out ourselves. And so do you think that was a mistake in retrospect that you hadn't taken care of it? Or do you still feel like, well, we got us to where we needed to be and we figured it out? Or did you end up having to, what came of that Haskell?
So I think it was both a mistake and not a problem. I'll explain both. It was a mistake because I continued to learn the lesson from that experience that if you don't do something that is important regularly, you're not going to be able to do it as well as you should. That was a big thing I took away from extreme programming back in the early days of agile software too. You know, Kent Beck would always talk about that. You know, if it hurts, do it all the time. Therefore, you'll figure out a way that it's not going to hurt. And I've had that in my mind ever since with everything I do. And so, like, we had a very critical system that if we had to fix a bug last minute in the middle of the night would be very difficult to do. That said, we had created our architecture in such a way that the system didn't care that it was in Haskell. The system had no idea what the implementation was. When I say, you know, you got the code and you got the system, right? So what we care about is creating systems that, you know, do things that people care about, obviously, but we don't care about the code. The code is something that we have to make so that we can have the system. And our system was done in such a way that the pieces of code didn't matter, and the structure was such that it was planned that we would throw code away. And so what we did was replace that Haskell code with Go. And we did it in less than a day because it was a tiny piece of code, as was every service in our system. You know, the whole microservices idea. We took that to an extreme. And I would always say to people, it's okay to create code in any language you want, as long as it fits a certain set of criteria. And one of them is I'd hold up my hand and spread my fingers apart and say the code has to be no more than this big. So basically, like, you know, less than a page on the screen. This one wasn't really less than a page on the screen, but it was small and its interface was clear, and the way it fit into the system was dictated by the system, so that it was very easy to just swap things in and out, and therefore it wasn't a catastrophe at all.
You know, I wanted to talk with you a little bit about overseeing engineering teams and having a lot of exposure to different types of environments, I'm sure, over the years. For those listening that may not be familiar with what Wunderlist was, you give a quick little overview of what it was and what point into the organization did you join? Had it already been built out for a little bit, or did you come in early on?
Yeah, I came in fairly early, but not at the very beginning. So I wasn't a co-founder of it. What it was a project management application. At the simplest, it was a to-do list. That's why it was called Wunderlist. But it was actually a fairly feature-rich project management application where you could have teams that synchronized lists and organized projects. And we built our own real-time sync protocol for the entire thing, including comments and everything else. So you could line up devices and click one and see them all change at the same time. You know, to some extent, it was a very simple, stupid thing, like everyone's hello world is a to-do list. But then at the same time, it was a multi-master distributed database system with a sync protocol. And I came in when it was a to-do list trying to be a real syncing multi-master database and failing hard. But the team had built something that users loved. It was already, I think there were 1 million users, but it had fallen apart, and they decided to rewrite it. So they created this Wunderlist 2, which, you know, was a big product launch, but also a full backend rewrite. And the backend that they created right before I showed up proved to be so incapable of dealing with the load and sync problems that one of the investors actually told me when we did Wunderlist 3, which was my version of the rewrite, if it works for more than a couple of seconds, you know you're doing pretty well. because Wunderlist 2 had fallen apart so poorly.
Oh, no.
And by the time I arrived in Berlin, which is where they were based to start the work as CTO for this company, they were reeling so much from this launch, which happened on a Christmas day, which wasn't nice for a team full of people who mostly celebrated Christmas, that no one had changed anything. They were afraid to touch anything. They were just absolutely paralyzed by fear. Because anytime they would change and do a deploy, the systems would start crashing and people would say their lists weren't syncing, they couldn't log in, all this stuff. So that's the background. From there, we undertook, I guess, a 1.5-year project to fully rewrite it and relaunch the whole thing, client to server, front to back.
One of the things that I didn't know that they went through that many steps or at least rewrote it multiple times like that. I know that there was a rewrite at one point. And I also really loved Wunderlist. I was a little sad when it went away. It's one of those, that's what happens, but it was a great tool to collaborate with other people with. And
for what it's worth, it still exists. It's called Microsoft To Do.
Yes.
Same code.
Is it?
So good. It is, yeah. It is. It's really good. People like to get caught up in the, Microsoft destroyed the product thing. Actually, I decided as the GM for it to call it Microsoft To Do and change the design and then change the backend to sitting on top of Exchange, believe it or not. And that's a whole other thing that was a big surprise to me. But yeah, it still exists. But anyway, thanks for being a user.
I mean, we'll have to go back and give that a shot. I think about when you're coming into these types of situations and, you're talking about like the idea of having these microservices and making them very easy to rewrite. One of the things that I encountered in the consulting side of things is that companies will bring me in or my team in to help out with a situation. And sometimes companies find themselves in a weird scenario where they really embrace microservices and they did a lot of that, but then their team got smaller afterwards at some point. And then there's a few people having to be responsible for a lot of services and they're feeling somewhat spread thin and also remembering like, oh, I'm doing the job of multiple people because there was more people, a year ago working here. And so they kind of hit this interesting point where like, well, we thought we were going to scale a lot more than we actually ended up doing. Where do you find that kind of balance there between in a startup environment where you're trying to be proactive and plan for if this thing does get some traction and there's millions of users using this thing versus maybe a smaller app where it's not, how do you weigh that up to be like, how far should we go down into the optimizing for the future versus like what we need over the next, say, short term?
That's a great question. And I have 2 ways of answering it. I'm going to do both. So one of them is like, how much should you future-proof your architecture and your application from the beginning, like in a startup? And the other is about microservices and whether that's unwieldy for small teams. And I want to talk about both. So the first one is I don't think you should future-proof at all. Twitter, when it launched, was a database-backed web application written in Rails. Probably, I think it was like Rails scaffolding first when they launched it, which if you look at what Twitter became, which is this like intensely scalable bunch of computer science problems, really. And then you say, yeah, this is a database-backed web app written in Rails. You would think whoever did this was an idiot. But actually, they had no idea where it was going to go from a business perspective. So had they not created the stupid version in the beginning, quote unquote, they never would have actually had the problem that led them to have to create this like really elegant architecture that the team created in the future. Had we not had the massive fail whale, embarrassment scaling issues, then the choices that were made that led to those would have meant they never would have had the fail whale and they never would have had the success afterwards. So, in general, I think whether it's that or Wunderlist was like a PHP application in the background, the most naive PHP application with whatever the grossest front-end client, write it in HTML and deploy it on iOS thing was at the time. I can't remember what it was called because it was many years ago. That's what they did at first, and users loved it. So it's almost like they created a prototype and they got 1 million users, I would not have used that application for long because it was so clunky, but they proved out the thing and then they hit a real wall in terms of scalability. And that's when they started trying to solve the problems. That's the right way to do it, in my opinion. Do you want to talk about that more, or should I tell you about microservices and whether
but as far as like early on in a startup, trying to balance that and like don't optimize for a feature you may or may not have, trying to like get things in front of users, prove that there's some interest, keep building on it, and then those problems will surface themselves. And if you're scaling and you can pay for it to invest in those long-term things, you'll do that. But at the same time, you're like not wanting to shoot yourself in the foot too much where like we don't want to cause pain for ourselves, like too much pain in the near future. And the companies that are potentially paying for these things, whether or not was Wunderlist founded by people that were software developers, or do you feel like there's a difference between organizations that start where they might bring a developer in and be part of that, or if it like company organizations that are building like an MVP, and they're kind of mostly run by programmers, and they understand what an MVP is and like know that they can revisit this, versus the scenario where it's more like some product people that hire and some engineers that come help them build their vision. And there's a disconnect of like the company paying and investing in that initial version of something and thinking like, why can't this now scale? Didn't we plan for that? Versus what the developers are like, that's going to cost more time and money to do that. And do you feel like there's like, that's a cultural thing with different types of organizations people need to kind of make sense of?
That is a really important point. Yes. Wunderlist was the main founder was someone who was kind of a programmer. Like he certainly would have called himself that then, and now he doesn't at all. So, he's not like us that have really fetishized the technology that we use. But you're right. Like I'm an investor now, full time, and I shock many of the people that I talk to who are non-technical founders when I say, yeah, of course your architecture isn't scaling. It was the first version. You're probably going to have to throw it away. That's the way it works. And I tell people that even before they start, especially when they're non-technical founders. People don't realize that's going to be the case, but it almost definitely will. So far, I haven't found like the perfect architecture that creates the right blend between the future and flexibility and what you need to do in the now. Although you might say that like just use Elixir and Phoenix and it'll be okay. I don't know. Something like that might work depending on what you do with it. Probably not. But yeah, that's a big problem. Business people get shocked. And even in the cases of startups that do this with technical founders, maybe their investors don't understand it. So, I had many conversations with our investors working on Wunderlist. We were on the third rewrite, so when we proposed we were going to do a rewrite, it was not something that they were happy to hear. And they also didn't understand why that would ever happen. Does that mean you're incompetent? The answer is no. There were certainly some questionable decisions made on the second rewrite, but it was not a problem of incompetence. It was a problem of moving quickly and trying to find the market and adapting and figuring out what the product should actually be. You can't make an architecture for a product where you don't know what the product's going to be unless you make something that's so flexible no one can use it.
Hey folks, it's me, Robby. I want you to take a moment and close your eyes. Now picture your code and your applications as a symphony. Now to keep that symphony playing smoothly, you need an orchestra of tools. That's where our podcast sponsor, AppSignal, takes center stage. They combine the elegance of error tracking, the precision of performance monitoring, and the harmony of logging into one symphonic suite. Whether you're composing with Ruby, jamming with Elixir, orchestrating with Node.js, or harmonizing with Python, or maybe even a little bit of flourish of JavaScript, AppSignal's got the sheet music for you. And here's the crescendo. Plans start at just $23 US a month. That's gotta be music to your budget's ears. Plus they're certified ISO 27001 and they dance the GDPR and HIPAA compliance beats. So don't miss a beat, my friends. Head on over to appsignal.com and tell them that your good friend Robby from Maintainable sent you. Now, open your eyes and let the symphony of smooth coding begin. Let's get back to our show. I know that you'd also mentioned like using microservices and such. And so what's your take on like, is there a balance there of like if a team's too small, like would you recommend that teams start really experimenting with that or not?
So I don't think there is a size correlation. Like I didn't start doing microservices architecture because I thought, hey, I've heard of this microservices thing from Fred George. Let me try it. What I did was looked at the problems that the team was having and that the product and service was having and thought, well, how can I solve these problems? And there were a bunch of issues with coupling. In fact, everything really comes down to coupling, I guess, but it's like runtime coupling and code time coupling, and even like human coupling, whatever, in terms of like being dependent on each other in ways that you shouldn't have to be, databases, et cetera. And the first thing that occurred to me was like looking at this they had created a monolithic Rails application with a monolithic database. And ironically, even a sync API that required monolithic interactions with it, as opposed to like small changes that you could post into it. I thought, Man, I wish this was small, because if it was small, then it would be easy. And by small, I mean the code base. That'd be great if that were small. The database, it's huge. So one of the first things I suggested, sort of out of jest, which these days doesn't sound so crazy, was maybe every user should just have their own separate database. We can just use SQLite. We'll host it on a server, and then we'll have a process that can read and like rehydrate itself and save to the SQLite database. And therefore, instead of dealing with trying to scale this massive database, we're dealing with a system for messing with a bunch of small databases, not scaling them, because for the same reason that I would hold my hand up and say code shouldn't be larger than this, databases, all problems are better to deal with when they're small. And in fact, I'd say like every hard problem in the world will be solved only when it is decomposed into smaller pieces. And then that is decomposed into even smaller pieces, and so on until it's easy. That's why I always used to love test-driven development when I learned about it. Not because I wanted testing. I think like tests in software, unit tests rarely make software more maintainable. Usually they make it harder to maintain. But the act of writing the tests makes the software more maintainable and also easier to write. So you have a hard problem in code and you start writing, well, just let me just do the easiest thing I can think of, and we'll just push the complexity down to the next level and we'll solve the problem there. What I find in TDD is you start with that and you keep pushing the complexity away, and eventually you're at the end and it never was difficult because you just keep going, down the tree. I started thinking about, I'm taking a long time to answer this, but I should probably heed my own advice and have small answers. I started thinking about, well, how could we make the problems smaller? How could we make it so that when we deploy one piece of code and it's screwed up, because it is going to be, you're always going to introduce problems in production, and you shouldn't try to pretend you're not going to and put processes in place to avoid it. That's a waste of time. How do we make it where when we deploy problems, it doesn't break the whole system? So at least just one feature, you can't upload files now because someone screwed that service up, versus you can't do anything because someone screwed up the file upload capability, which is what was happening and happens on many projects. And out of that came this structure that was an architecture and a system we created that happened to have small pieces of code that could speak to each other in ways that were well-defined and fairly well decoupled as well.
You mentioned SQLite. I'm actually just from an implementation approach. So everybody had their own database. Was the desktop app syncing a SQLite database locally?
We didn't do this crazy architecture. Right? Well, we did. We sort of did, but it wasn't. This was really just to get into people's brains. How can we make this into small problems? The ultimate architecture that we came up with and how it overlapped with this idea was, of course, local first. So on the client, you had probably SQLite, because most clients have SQLite somehow. And then on the server, every client would connect to a Scala actor. So basically like an Erlang process. And that Scala actor would act itself as a client, and they were connected via WebSockets. So the Scala actor would deal with synchronizing with all the backend systems, and it would do it on a really fast network connection because it was on a server. But then it could maintain its own in-memory representation, and it could even like save that in-memory representation out into a cache file that it could then load next time it boots up. The sort of common Erlang process pattern. Though we did have databases that were large in the background, we still were able to sort of interact as if we had these small SQLite databases that I envisioned. And then we did the kind of cheap, crappy version of sharding, where we just at least took every table out and put it into a separate database that could be on a separate service that could therefore have, different kind of scaling bottlenecks and whatnot. So we broke the massive database into a bunch of massive databases, honestly, and never had to break it down further.
When in those types of scenarios, you mentioned that you didn't really care what people were using to build in those services. Did you kind of keep like a core group of like, these are the technology stacks we're okay that you're condoning to use as a team? Or do you kind of let that be a little bit more, let the team decide on a case-by-case basis?
It was case by case. And it was even okay if you were an intern and by a whim you wanted to do a service in Ponylang or something, and I just use that as an example of one that's, not in the top 10 programming languages in the world. That was an intentional choice I made. Sort of like through my career, I've been collecting ideas that I want to, or idea isn't the right word because it sounds like you're going to join a Frankenstein shop if you're working with me, but it's more things that I have determined are lessons that I've learned. And I say it that way because I might be wrong, but I've determined that there are lessons I've learned. And that was one where I just didn't want to have a team with anyone who was cynical because they didn't get to use the technology they wanted and they felt like they were stuck. Because I've been that person. I've been the person back in the, I don't know, late 90s, early 2000s, stuck on some terrible J2EE stack, wishing I could be a Ruby developer, but I couldn't because it wasn't in policy and we hadn't all agreed at the company. So here I thought, well, let's just do it in reverse. Even for those who really don't want me to do this, anyone can deploy in any language they want, but what they have to do is make the code small, make it fit into our monitoring and deployment systems and metrics collection, a couple of other things, and then have at least one other person who will do it with you and who will actually understand how it works as well as you do. That's why we had two that could do the Haskell service. And we literally did have interns introducing new languages. Like our first Elixir stuff that we did was an intern that just loved Elixir. And I didn't really care to mess with it because I was happy with what I was doing, and it worked out fine, of course.
That's interesting. I end up talking to companies where, going back to the point about when companies might have to downsize their team or people leave for all the different various reasons, they don't need as many developers now. And the people that are still around, or maybe it becomes a recruitment challenge to find people that can work on a wide variety of platform frameworks and platforms that they may or may not have experience yet with. And if you have a smaller subset of frameworks or technologies that your team needs to know about, you could be a little bit more, maybe, I think the theory is that you can then be more targeted about who you're looking to recruit, because you want to find people that are going to be excited to work on that technology stack or whatever. But in your environment, you were kind of like, let's experiment, let's try lots of different things. But I also know that there's teams that are like down the road, like now I'm kind of stuck doing something because of someone's experiment. They were able to put that on their resume and they're no longer here to take care of the thing that they built. So where do you find like a healthy balance there between letting your engineers wander and experiment with these things, but also they may not be the ones having to maintain it, a couple of years down the road?
Yeah, there are a couple of ways that I approached that. One was everything had to be small, as I said. But more importantly, the thing that we put the most work into was how the system worked overall. And so the reason that I mentioned that obviously is when you talk to this service that was written in Haskell, for example, and there were only two people who knew how to do Haskell, the way you talk to it was the same way you talk to every service on the network. Whether it was we initially generated a bunch of Rails apps. That's how we started the new rewrite in Wunderlist 3, literally with a shell script with a bunch of words that then went and generated the apps and checked them into Git and everything. So the way the Rails apps would respond would be exactly the way the Haskell, Elixir, Rust, Go, etc. apps would respond. They were small, which means the work to switch them out would be to rewrite the Haskell thing in Ruby or whatever, and then just deploy it. There's no patching anything else because they're just sitting there, they're talking plain text and they're working, and it's over HTTP. It's basically like plain text HTTP with RabbitMQ in the background, pushing a bunch of queuing and allowing messages to be broken up into smaller pieces and work to be broken up into smaller pieces. So why am I going on and on about this? What would have been terrible is if we had created this overall system in a way that was difficult to figure out how to use and maintain. And there was probably a period of time where if one of the couple of us who had built the system part left, that would have been a problem for us. But if someone who wrote the Haskell service left and there was a bug overnight, then I or someone else on the team could wake up when we got paged and rewrite the service and go and deploy it. Like literally, it's that little code and that easy to understand. And so what I wanted to do was take the focus away from the code and move it to the system. So it was all about, how do we know what's flowing through this thing? How do we know it's performing well? How do we deploy it in a way that we feel safe and that is standardized for every single service? And that was like, kind of a blend of chat ops. And this was like before Docker really came to popularity, or as Docker was coming to popularity. So we created our whole own sort of AWS-based system for doing what you do with Kubernetes and Docker today, probably. But it was the system that really mattered, and the way sync worked and the way data flowed through the system. And then literally every single service could trivially be replaced in any language. So if you had to lay off your whole team except for one person, and the one person didn't know how to deal with Haskell or Go, then they could just rewrite those services in Ruby, because they probably wrote most of the Ruby ones anyway. And it would look like that, and you'd have to spend more money to run them because Ruby was less efficient than Haskell or Go to do what we were doing.
So you could kind of rely on the fact that people could somewhat reverse engineer it there's the expectation of what the output is. Was there, I'm assuming you put a lot of emphasis on documentation or maybe your test suite to kind of encapsulate, or maybe? No.
No documentation or test suites, but very, very simple human readable interfaces where you would look at the system and just get what it did.
Mm.
And mostly it was CRUD, and most apps are CRUD, so create, read, update, delete.
Yeah.
So, as long as you get how the synchronization system would work in Wunderlist, which defined a lot of the CRUD objects, and it was basically a tree. You can imagine almost any sort of synchronization problem, data synchronization problem being represented as a tree, where you have some sort of a root thing that you're trying to synchronize and it has child nodes in it,
Right.
whether it's a document or a list or whatever. And so the services in the network were mostly about the various sort of nodes and branches in the tree. If you knew how that worked and there was documentation on that, then you didn't need to have documentation on the service because all the different operations the service might do. And then there are some custom ones that there was a way of flagging what those custom sort of operations would be. And all of the inputs and outputs are well known, and the way that you talk to it is well known, and it's consistent across the entire thing. You don't care about the implementation about the specific service. You don't even care about the specific implementation of how messages are processed in the bus and how the sync works, because that was also tiny and very well contained and decoupled from everything else. So you could continue to do stuff on the web with Wunderlist, and the whole real-time synchronization message bus in the background that would power things could go down. And what you would notice is maybe you have to hit reload sometimes to see the changes, but otherwise everything's still working.
That's fascinating. I'm curious, you mentioned that during the acquisition process, whoever company's acquiring a piece of software, they're doing their due diligence and reviewing the code and maybe going through the exercise of maybe trying to see if they can get the app up and running. Out of curiosity, was documentation something they pointed out that was problematic and something you had to address at that point? Or was it no, we could figure it out. It just took a bit of time to do that. And Microsoft was like, okay, great. Or did they have an expectation you didn't do enough of documentation to make it make sense for this acquisition process?
I think they mentioned it, but no one really cared when
Okay.
they saw how it worked, because there was documentation for the full system, as I said. And when you really lifted the covers on any of these other little small systems, you would get what we advertised. You'd get, oh, this is a trivial thing that anyone can figure out, anyone can replace. We could rewrite each one piece by piece in .NET. And we had some proof too. So we had initially launched everything in Ruby, and then we went live, and it was a combination of Ruby and Clojure mostly, with some other languages sprinkled in. And it was very expensive to run because the thing we weren't going to do is crash on the first day, like the previous rewrite had done. So I think at one point we had 800 EC2 image servers running to process the load for the launch. And there was no blip. It was a very easy day. And so to save money over the next couple of weeks, we rewrote a third of the code base in Scala, service by service, and didn't tell anyone in the business other than, I was the CTO, but we didn't go to the CEO or the board and say, now we're going to do this rewrite. We just did it. And the code changed dramatically from there. I think 6 months later, more than half the system had been rewritten on the back end.
That is so the opposite of what I expect to hear from organizations, or thinking about, at least on the podcast, I'm always at what point do you feel like it makes sense to look into a rewrite? But do you feel like a rewrite in the context of it, well, these are small little individual pieces of the overall system. We're not doing a rewrite of the whole system. We're just kind of going in and being strategic about certain areas that are maybe not super performant or what. And if someone wants to experiment with something else, it's going to save us some money, and we're going to reduce the number of EC2 images being run right now. I'm assuming that was a big part of how do you help the organization save money now? And it's not just just throw for a long time is just throw more hardware at it and that'll be the problem, but it's expensive also.
Yeah, going into the launch, the priority was keep it up and make it perform. After that, the priority was don't run out of money because of how we're running this thing. Before the launch, several months before, there was a contentious board meeting that I was in, and one of our investors who'd been with the company since very early and gone through the other botched rewrite was just really upset when he heard we were doing a rewrite. And I said, I just don't think there's another way to do it. And by the way, I wrote a long article series 6 years before that about how you should never do a big rewrite, called The Big Rewrite. And I said, okay, if we launch this and we have to do another rewrite, if you hear me say that we're doing another rewrite, I will just quit the industry and publicly admit defeat and tell everyone I've failed. We're not going to do it. And so we did rewrite a bunch of the system afterward, but we never told him. And we never, I would say, incurred the cost of the rewrite. We certainly incurred the cost of typing the code in. But imagine it had been in a monolith and we were trying to save money. It probably would have been a rewrite, right? So like I hate to hear that a team is about to do a rewrite, but I think that's because in my career, and there have been a ton of these, what happens is I encounter a project where the system and the architecture need to be replaced. The database, the structure of the database, things that are really hard to change need to be replaced. And so you have no choice but to just kill it and replace it. And what we did here was more like how a human body continues to exist while its cells are constantly dying. I mean, like you and I are just puddles of death right now. Everyone listening to this is just like constant death and rebirth constantly. And that's what I was trying to go for, because I look at myself and I think, well, I don't maintain myself very well, but I'm still here and I'm almost 50 now. So how does that work? Well, a bunch of different things, but one of them is this constant renewal that biology has evolved, and that's how I thought about small components in the case of Wunderlist. And we're only talking about Wunderlist, but really this is still very much how I think about systems. So you can, it's not just a story about Wunderlist, it's really a story about how I think about systems and what I've learned in my whole career. Small components, not only that can be replaced, but should be replaced constantly. I sort of started the podcast with that. Like if it doesn't change all the time, then there's probably an issue with it. That's also the case with servers. Like I remember in 1999 being so proud that my huge Sun server I had set up at GE was running for over a year, without being rebooted, because that's the way you thought about things back then, uptime. Now, if I see a server has been running a process for a year, I think, oh God, how can we deal with it if it goes down? Or how can we replace it? How can we upgrade it? It's scary. But if it's been changing constantly all day, then I know change is something that it's good at. And that's what well-maintained, and maintainable software needs to be, is good at change. So I think we created a system that didn't need to be rewritten because the components could and would be rewritten frequently. I've even thought of like over time of like, what if there were some sort of a system, maybe as an experiment, where you create an architecture with, a good way for pieces of code to communicate, and then you put rules into your, I don't know, get pre-commits or post commits that literally delete code on occasion. And so you can't actually get the build to pass unless you rewrite a function or, whatever that means. You rewrite some piece of the code. I think that might ultimately be good. That would be annoying in the short term. It might be an interesting constraint to put on a team and see what happens.
Just remove this bit of code and see how you address it. That's interesting. One of the other topics I wanted to dig into with you, I was looking through my notes and highlights from one of your books, The Passionate Programmer. That's coming up on 15 years?
Yeah, the first edition of that book was in 2005, so it's almost 20 years. But it used to have a different name. It was called My Job Went to India, and all I got was this lousy book.
Thinking about the state of the world, the state of at least maybe our industry, the tech industry, and we're recording this, it's middle of January 2024, continues to be a lot of layoffs and stuff happening and in the industry. Having been around the industry for such a long time now, do you feel like there's anything surprising or atypical from this kind of time that we're going through versus say the other, the .com, the 2008, the other things that people often cite as being other these moments in the industry? And like, what's your kind of take and read how to compare to past cycles?
There is one huge difference. So like past cycles where developers were laid off were almost entirely about economic cycles. Now we have one of the biggest changes in technology I've ever seen, specifically poised to totally disrupt how software development is done. And I would be surprised if that doesn't cause just mass casualties in the software workforce in terms of jobs. And I'm talking about AI and LLMs and this whole sort of thing, probably quite obviously. So I don't know. I'm a VC now, which means I don't actually have to write code if I don't want to. I do still every day write code for my job even. But I think to myself, man, if I were, let's say 10 or 15 years younger now, I would probably be pretty stressed about this moment, about what I'm going to do with the rest of my career. The way I think I would approach it is I would start thinking about software agents as my colleagues and then figure out how to create software such that they are maximally productive along with me.
Mm.
And in fact, one of the questions I would have, like, had you asked me, how do you make maintainable software? The answer might have been, for whom? Because I think there's a time coming, I will say in the near future, because no one's going to check me on it, where it is mainstream to have software writing the software for us. And certain architectures will do better for AI agents than others. Like probably the architecture I created at Wunderlist is similar to what you would want to do. But I bet, and I haven't done really the thought around it, I bet there are things that you might even lean to in an architecture for software agents to collaborate in that would be bad for the humans. So there might be trade-offs that you make that are pro-agent and anti-human in order to be more productive or to make it easier for the agent to maintain. So yeah, I think everything is changing, and it's fascinating. It's exciting, but also sort of scary.
Yeah, it's scary, and I'm assuming you think it's scary because it's just a big unknown. We don't quite exactly know how this is going to pan out. I mean, curiosity, are you playing with much tooling yourselves as are you taking advantage of Copilot or anything and trying to integrate that? Do you have
Yeah,
to?
I don't like the Copilot type approach, which isn't to say that I think it's bad. It's not what excites me the most. Like Copilot, I feel like that is a way to make your editor much, much smarter, and it's still very focused on a programmer typing things into an
Yeah.
editor. I think it's not short-sighted because it's revolutionary, but if you sit on that as what the future is for AI assisted software development, that's short-sighted. I'm more excited about processes that can do things. Like imagine, you don't even have to imagine GitHub, which is the primary repository of software in the world at this point, because it was created by programmers for programmers, really good programmers for programmers. Everything is API drivable, everything's automatable. Even PRs, issues, comments. Like I've known for many years that there's no way to know whether there's a human or a bot doing the things on GitHub. And we've seen negative stuff happen because of bots, and we've seen positive things like Sneak SNYK, a security company. The first one I saw and met where they were doing pull requests using bots that would help upgrade your dependencies, like what Dependabot does today too. And a light bulb went off, and I realized, oh, this is okay because GitHub has created this concept of a pull request, and everyone's used to doing a review. So it's, we don't care if it's a bot or a person, because at least someone can go do the review and it's a separate step.
Right.
And I look at something like GitHub now and I think, imagine if there were an economic incentive to like fix all the issues in all the major open source projects. Well, what I would probably do as a software developer now is work on writing bots that try to fix the problems in these repos so that I can get paid, and then I could just let my bots run all the time. And I imagine a scenario in the future where there is this sort of, maybe this is like going to be dystopian, but there is this like economic drive and competition where people are just pouring all their resources into building maybe even like specialist bots that can do stuff in software repos, and they get paid for the performance of those bots. And it's like totally inefficient because there's duplicate work happening, but it's not people doing it, so it's okay. Like that's the sort of disruptive sort of activity that I'm more excited and terrified of.
We'll be back with our interview with Chad in just a moment. Hi, it's me, Robby. I just want to say thank you for making time to listen to the podcast. If you're finding these conversations valuable, please stop right now, share the URL with your peers in your Slack channel, Discord, LinkedIn, email. Just like send a relative you haven't spoken to in 3 years a link to this episode and say, hey, you should listen to this episode with Robby and Chad Fowler. Or you can just go to Apple Podcasts and write a review, leave us a 1 to 5 star rating. Be honest. You don't have to, I'm not looking for 5 stars all the time, but please spend a couple minutes doing that. That'd be amazing. Also, is there someone you think I should interview sometime on the podcast? Shoot me an email to Robby with a Y at maintainable.fm and state your case. And now let's get back to our interview with Chad Fowler. No, that's fascinating. I remember I heard someone talking recently about thinking about how different AI and tools could potentially help us. And one thing I thought was interesting was his take of when you're looking to recruit people on your team, to like humans to join your team. Also, you won't just be recruiting them. You'll be and there's and their skills on knowing what programming languages and how many years they've done, the types of systems they've had an opportunity to work on. But you're also kind of hiring their, I'm air quoting, AI buddy, thing that they've helped train and kind of work with them along the way. And if assuming that it continues to learn with you and you can take that version of your AI bot with you with your job, you're hiring what their bot can produce as well to some degree. And
Yeah, interesting.
that feels like an interesting way to think about who are you showing up with? Like, was it like the second brain or brains if there's multiple bots? And you're like, oh, I have this one job, we do this with this stuff, and I have another one for this kind of work. And how do you share that, as you join a company or something? And how do you recruit for that?
Yeah, I like that idea, although there are some problems with it. Like it got trained on your last job from the code that you and other people did, that sort of stuff. The other one is like, why would I have a special one that I bring with me? And I know I just said maybe I would, right? But like if you're hiring me, the idea that each of us would have our own that we bring, that we've trained based on how we do stuff, I'd rather have one trained on people who are way better than I am. And maybe I don't bring it with me, but the company's just already paid for it.
They're licensing it.
Yeah. So like if there is something special I can do in software development, great, I could train a bot. But I think I'm probably better off licensing that or running it as a service that people pay for versus just having it be this assistant that I bring with me. So, I probably don't see a future where this specific scenario plays out, though this is fun and in the sci-fi type direction that I kind of have in mind, because I don't think that each person is really qualified to create anything special. And, you have the world's resources available to you. Why go with, just what Chad or Robby has trained this thing to do?
It's fascinating. And maybe my bot works best when it's collaborating with Chad's bot, and like they know how to work with different types of people. So like, here's me and my team of our bots, and
or maybe I hire you because, one of the things that you do well is use these things, like it might not be that you bring them, but you're a good collaborator with these. And maybe this is probably the most obvious thing you could say, but a developer who knows how to orchestrate a bunch of AI and tools and automation and stuff is better than one that doesn't. Probably, almost definitely. Could there be a world in 2 years that that's not the case? I don't think so, right? So it might not be that you create the IP yourself of the bot, but you are a person who knows what to do. Like, I mean, today, even I spend enough time with these tools that I'm probably in some top percentile of people, even among developers, that can get things done with them because I've done the stupid things that didn't work and I've figured out how you have to talk to it. And I figured out what the inputs and, and prompts and junk are. And so if I were a developer now, that's probably a thing I would show people that I can do, a developer looking for a job, because it still is a differentiated skill. And I imagine as the technology evolves, it will continue to be for quite some time.
We should probably check back in with each other in a few years and see where this all kind of plays out. I'm fascinated by it. I'm trying to not be intimidated and be like, who needs my special skills anymore? You can just go talk to a bot and probably knows more than I do. And that's not a bad thing. One thing you mentioned in your book, it got me thinking a little bit. I remember maybe even made a reference to musicians as well, because I know you're a musician. The idea of being like, not being the smartest person or the best person on your team when you join one. So I think about that and you hear that kind of, commentary. But what is it if you are the better person in the team? Where does that leave you if you are the smarter person in the room? I think about that, like thinking about my own band, for example. I'm the least skilled person in my band. I just have other attributes that the band seems to want to stick around and keep working with me on this project. But I'm always like, this drummer is amazing, and they have I'm like, why are they with me? Why don't they go work and be the least skilled musician in their band? So I was thinking about that and being like, I feel like there's a little bit of at odds thing in my brain about maybe you just hope that they don't realize it one day, or
it's good that you brought that up. Like I was going to answer this differently until you started talking about the band, which is ironic because this is a quote from Pat Metheny saying, always be the worst person in the band, every band you're in. I think your drummer and Pat Metheny are, I mean, I have to take your word for it in terms of your drummer. I'm not going to say that your drummer is better than you, but, let's say your drummer is better than you, then that is in some objective sense true. Like they have skills that you don't have. They could play some music that you couldn't play. But it turns out that music is subjective. As a musician, you don't want to play with just the most skilled people. You want to play with the people with whom you make great music, or with whom you make music that you enjoy, which is not even the same thing, or with whom you enjoy making music, which is not the same thing. I think that's true as a technologist and as a developer too. And part of it, I would say, without claiming to be some sort of musical genius or, all that accomplished as a musician, is you get to a point where you yourself realize that music is not a sport, it's not quantifiable, and there isn't such a thing as good or better or worse or worst, but rather there's just like, what are we going to do together and how do we complement each other? And I think as a software developer, that's how I would approach it. So as I've grown, because we established I wrote this book a long time ago, I was at a point then where I was trying to just actively connect myself to people who just outclassed me so that it could raise me to a new level. And it's important not to let the standard down. But what I'm finding today is that I meet inexperienced developers that I work with on something, and they're just better than me in some way that way outclasses me. And I've now forgotten that there's any sort of a hierarchy. And I can't even fathom, maybe I suck, I don't know, but I can't fathom that I might be the best person in the band, as a developer, so to speak, because I know what my skill holes are and my limitations. And I work with people and I find the things in them that I don't have. So there's still something about what company you keep. And I think as you mature and you progress as a developer, you will find an intuition for that and you'll find the right balance. But there is a certain point where you can't just go actively find, like, Kent Beck, for lack of a better one to come up with now, to go pair with so that you can learn about, software development, because there's only so few of them, and eventually you become closer and closer to the ideal that you were looking for if you continue to progress in your career. So you just realize that the world is full of things to learn, and every person has, that's not true. Most people have something to learn from.
That's very true. Yeah, thanks for kind of diving down that little bit of a rabbit hole with me. Just another thing you mentioned in your book was mentors tend not to get laid off. Do you feel like that still holds water today?
It depends on whether that's all they're doing. If you hire someone, because I've seen since then people getting hired into organizations where their whole role is to go around helping people and not to actually do things. I could imagine as an aging software developer, if I were still doing software full time, I might do something like that at a big company. And what would probably happen is I would progressively get detached from the day to day and not really know how to do the things myself hands on. Then I think I would be at risk of being laid off. But if I'm like the senior developer type whose mentoring takes the shape of pairing together and working on stuff and leading by example, I think that's still true. And I think the mentor in that scenario is also the one that continues to be employed when AIs are doing a lot of the work, because they know how to probably orchestrate these things and instruct them, and they can kind of navigate in complex situations.
That's a good way to think about that. And as some teams have gotten smaller in the last few years, and there's maybe less capacity for that. And if you're thinking like, you got to show your work, what you've been working on, you kind of have to be a bit of an advocate for yourself if you're a individual contributor in an organization. And not that should be hopefully not going to work every thinking, I just got to make sure I'm standing out a bit more than all my coworkers. That's probably not necessarily the healthiest way to think about it either. But, and I'm going to include links to your book and stuff in the show notes because I think listeners should check it out. I think there's a lot of very important, relevant details in there that still, I think, hold water today. But yeah, thanks for, kind of diving into that with me. I have a couple of quick last questions. I know you're a very busy person, Chad. And is there a non-technical, non-coding, non-software book that you feel like you recommended to a lot of peers over the years?
Yes, there are a couple of them, and they're both a bit embarrassing for different reasons. The one that is probably the least expected, but the one I've quoted the most, is a book called The E-Myth Revisited. I think the subtitle is Why Most Small Businesses Fail. And the reason I say it's embarrassing is I absolutely hate how it's written. It's written in this dialogue style, and I like nothing about the style. And if you start reading it on my recommendation and you don't remember that I said that, please let this come back into your head. It's not because it's a beautifully written thing, but the concepts are really important and have shaped a lot of my career, both in and out of software. And the sort of core thing is the author talks about how people start a business because they love a thing, so they want that to be what they do. So they start a business, and it turns out you don't get to do the thing when you start the business. You have to manage a business that does the thing. And most small businesses fail because people still want to do the thing, and they forget that they're doing a business. So I guess the entire thing can be sort of distilled into working on the business versus working in the business. And you can take those same sort of ideas and apply them to your career, to how you work in software on a day-to-day basis. Are you just typing code and finishing tasks? Or do you spend some time working on you and how you get that thing done? Even in the sort of microcosm of how you do it in a specific job, but then also the macrocosm of what am I in the commercial world and how do I fit into it? And what is the value of a software developer? And how can I make sure that I'm the best version of that thing based on the value that I provide, not based on what I do day to day in an editor? And I guess like the very specific thing that he talks about that has really inspired me is recommends to business owners and new entrepreneurs to create an org chart for your company, even if you're the only one there, because it will help you to figure out how to break what you do into a system, a hierarchical system with clear interfaces, and one big job broken down into a bunch of small jobs. Yes, there is a theme here. And then what you can do if you do that is you can go look at each node in your hierarchy and say, well, how do I measure success of that thing? If I hired a VP of whatever that is, how would I tell them how to do a good job? How would I measure their success? How would I communicate with them? What do they need to do a good job? You can then sort of role play if you do this for yourself and say, okay, now I'm in VP finance mode. This is how I describe what that is. And these are the outputs of what I'm supposed to do as VP of finance, even though I actually have all the jobs, So I find it to be very inspiring, despite a bit of a dull read, but I highly recommend it.
I second that. It's been a long time since I read it, but one of the things that always stuck out with me was there's some flashbacks to the org chart exercises and stuff, but thinking about you going and doing in a job for a while and setting up the system and process and then trying to put yourself out of that job by bringing someone in or someone else or automated solution, whatever the thing is that's going to take care of the majority of that. And you keep it and you can keep tabs on it, but you should kind of go around and then tackle the next thing and just kind of repeat that process. And that helped me think about a number of things for my company over the years. And it's like an ebb and flow thing. You might have to revisit those roles again, and take them over again, but know that you have some confidence that you can experiment it with differently in the future. Maybe it was the wrong person, or maybe you didn't do a good job of organizing that work, and so you take that feedback cycle. What was the other book?
Zen and the Art of Motorcycle Maintenance. And that one is also embarrassing, but only because it's maybe too obvious. That's the sort of book you mention when you want to sound cool to a certain subset of people. But just the whole idea of so deeply scrutinizing what quality means had a big impact on me. And that's why I've read it twice, which I don't normally do for books. And that's why I would recommend other people read it.
We'll definitely include links to those both in the show notes for everybody. Where can people best follow your thoughts and ruminations about software development and the tech industry and the unknown future of AI and your career online?
I guess I'm still mostly on the social media site formerly known as Twitter as Chad Fowler. I'd like to be somewhere else, but I can't find the community that is vibrant enough yet. Ironically, LinkedIn is also a good place. I'm finding these days that posting things on LinkedIn actually attracts the sort of people that I want to talk to about things. But yeah, please do find me there and say hello. And if you want to talk about these things, I would love to chat both in these platforms and even over Zoom or whatever.
That sounds great. If I recall, if anyone out there is working on a startup project, and are you open to talking to new apps and startups right now?
I am. Yeah. We do early stage investments. I'm at BlueYard Capital, and I can guarantee we were probably one of the nerdiest VC firms you ever talked to, in hopefully a good way. But yeah, I'd love to talk to people who are doing things, especially around stuff like generative code and in any form of what I was talking about earlier. Very interested in that right now.
I'll definitely include a link to your organization, your VC firm as well in the show notes. With that, Chad, it's been such a delight having you join us on Maintainable. Thank you for stopping by to talk shop with us.
Thank you.